The next several lessons, we're going to work on factoring a quadratic equation. And so we're calling it a trinomial because it has three terms, but what we're doing is we're looking at a quadratic that's in standard form. So this is a quadratic in standard form. Quadratic means the highest degree is 2, and it's in standard form because it goes from highest degree to lowest. So this is a degree of 2, of 1, of 0. Now specifically in this lesson, we're going to assume that a is 1. So the coefficient for our x squared value is a 1. So this is what it's going to look like. Remember, there might be a minus here instead of a plus, or a minus here instead of a plus, but that's what we're going to work on. And when we do that, we're going to focus right here. We're going to look for factors of c that either add or subtract to b depending on what this value is. So for instance, on this question, I start at the 15. I say numbers that multiply to 15, and some people find it easier to make a table. And in my table, I'm looking for numbers that multiply to 15 that add to 8. And so looking at factors of 15 would be 1 and 15. Those add to 16, so that does not work. Then I've got 3 and 5 multiply to 15, and those add to 8, so those do work. Now because they add to positive 8, I know they're both going to be positive. So positive 3 and positive 5 add to positive 8. These are the values that I'm going to use in my binomials. So here I'm going to factor this into x plus 3, the plus 3 from right here, and x plus 5. The plus 5 from right here. So I have a lot of students who get confused by that because they say, I'm looking at the original and the original has a squared, and when I broke it down, it's not squared anymore. But remember, I've got 2x's here and I've got 2x's here. If you're not sure if you factored correctly, let's FOIL it back out to check. X times x is x squared, so that's the squared value. X times 5 is plus 5x. Plus 3 times x is plus 3x, and plus 3 times plus 5 is plus 15. And did I end up back where I started? Yes, I did, so I know that I factored it right. Now this step, not necessary, but as you first get started, not a bad idea to at least do this check in your head to make sure that it matches back up with where you started. Let's take a look at the next one. Again, here I'm looking for numbers that multiply to 42, that subtract to positive 1 or have a difference of positive 1. Again, so I'm looking for a positive 1 here, but they need to subtract. So you might add subtract. So 42 is 1 and 42. Those have a difference of 41. That doesn't work. It's also 2 and 21. Those have a difference of 19. So that doesn't work. It looks like 3 and 14, which have a difference of 11. So that doesn't work. 4 doesn't go in evenly. 5 doesn't go in evenly. 6 and 7 have a difference of 1. Now here's where you need to pay attention to the signs. I need them to subtract to positive 1. So, or actually now I'm looking sort of at adding. I need them to have a difference of positive 1, which means negative 6 and positive 7 would have a difference of positive 1. So that's what I'm looking for, the minus 6 and the plus 7. So when I factor, I'm using x minus 6 and x plus 7. So again, I looked for a difference of 1 rather than a sum. So always pay attention to this sign. This one, as you can see, I sort of lied to you because I said a is 1, but if you'll notice, a is not 1 because there's a 2 in front. But I wanted to show you this one because it does have a GCF of 2. So once I take out that GCF of 2, I'm left with x squared minus 16x plus 48. And now I'm going to factor by looking for numbers that multiply to 48 that add to negative 16. So they have to add to 16. So numbers that multiply to 48 that add to 16. Let's see. again, you can start at the beginning with 1 and 48. If I added those, I get 49. That doesn't work. 2 and 24 would add to 26. That doesn't work. 3 and 16 would add to 19. That doesn't work. 4 and 12 add to 16, and that's what I want. So now I need to look at the signs. I need them to actually add to a negative 16. And if they add to a negative 16, that means it would be negative 4 and negative 12. Negative 4, negative 12. So again, keeping that GCF on the outside, I would have x minus 4 and x minus 12. Go ahead and press pause, try all 4 of these, then press play to see how you did. For my first example, numbers that multiply to 7 that add to 8 are 1 and 7, positive 1, positive 7. So b plus 1, b plus 7. Again, you can make your table if you would like. For my second one, numbers that multiply to 10 that add to 11 would be negative 1 and negative 10. Those multiply to 10 and add to negative 11. So n minus 1, n minus 10. Here, numbers that multiply to 90 that subtract to positive 1 would be 9 and 10. Those multiply to 90. I need them to subtract positive 1, so I need a negative 9 and a positive 10. So x minus 9, x plus 10. Again, you're welcome to FOIL any of these back out to check your answer. And on my last one, numbers that multiply to negative 12 that subtract to 4. So numbers that multiply to 12 that subtract to 4 are 2 and 6. And they, I want a positive 4. So I'm going to go with negative 2 and positive 6. So n minus 2, n plus 6. Just a side note, because I haven't addressed it yet, remember that multiplication is commutative, so I could have these in the opposite order, and it's the same answer. So don't worry about the order in which you write your binomials. Here are 4 more for you to try on your own. So try all 4 questions, then press play to check your work. Since both of my 2 first questions involve the product of 24 for my C value, I'm going to list all of the values that multiply to 24. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. For my first question, I'm looking for numbers that have a product of 24 but a difference of 2. And so I know that I will use 4 and 6. 4 would be negative and 6 would be positive, because those then would add to positive 2, but then multiply to negative 24. So that's x minus 4, x plus 6. For my other 24, I'm not looking for a difference of 2, but I'm looking for a sum of 2. And as you can see, this would be a sum of 25, of 14, of 11, and of 10. So none of these will work to have a sum of 2. And we know it's sum because of the plus. So this is considered prime, which means that it cannot be factored. For my third question, I'm looking for numbers that multiply to 40 that add to 13, and it has to be a negative 13. And so numbers would be 1 and 40, 2 and 20, 4 and 10, 5 and 8, and 5 and 8 is our winner. Remember, those both must be negative to add to negative 13, so a minus 5, a minus 8. And our last one, we have 18, so that's 1 and 18, 2 and 9, 3 and 6. I'm looking for numbers that add to positive 11. So I will use a positive 2 and a positive 9. So n plus 2, n plus 9. Last set all includes GCFs, except for this one right here. On this one, I would first divide by 2, which would give me x squared plus x minus 2. Then I look for numbers that multiply to 2 that subtract to 1. So multiply to 2 are 1 and 2, subtract to positive 1 means the 1 would be negative. So x minus 1, x plus 2. Here, my GCF would be 4. So 4 on the outside, and then x squared plus x minus 2. So notice I actually got the exact same thing as x squared plus x minus 2. So this one is still going to be x minus 1, x plus 2. Here, I don't have a GCF. I'm looking for numbers that multiply to 50 that add to 15, which would be 5 times 10. They need to add to a negative 15, which means they're both negative. So x minus 5, x minus 10. And the last one, a GCF of 2 would make this a little bit easier to factor. So x squared minus 15x plus 50. And then notice I've already factored that over here. So I just have a 2 on the outside, and then x minus 5, x minus 10.